In this problem, we are asked to find the solutions to the equation the square root of 3 tangent of 1/3 x is equal to 1. We will recognize that the period for tangent would be given by pi over b, our pi divided by 1/3, which is equal to 3 pi. Therefore, our solutions would cycle every 3 pi units. In order to find our equation, we will simplify this by dividing both sides by the square root of 3 and get tangent of 1/3 x is equal to 1 over the square root of 3. Therefore, we are looking for values of angles where I take 1/3 of their value, take the tangent of that angle, and I get 1 over the square root of 3. Therefore, if we let theta be equal to 1/3 x, I am looking for values of the tangent of theta producing 1 over the square root of 3. We would recognize this in the following way, that tangent of theta is equal to the sine of theta over the cosine of theta, and we want that to produce a ratio of 1 over root 3. Therefore, we would have the sine of theta being 1/2 and the cosine of theta being the square root of 3 over 2. This occurs at a reference angle or a quadrant 1 angle of pi over 6. We would now know that the tangent function, tangent of theta, would have solutions to the equation tangent of theta equal 1 over the square root of 3 at pi over 6 plus n pi. To find our solutions for our original equations, we really wanted 1/3 x to be equal to that general solution of pi over 6 plus n pi. Multiplying both sides by 3, I'm going to get x is equal to pi over 2 plus 3n pi for any integer n. In our next problem, we have a phase shift. We are asked to find the solutions to sine of x plus pi over 4 is equal to 1/2. Therefore, we are looking for values such where that x plus pi over 4, when I take the sine of it, I get 1/2. So if we let theta be equal to x plus pi over 4, we can find specific solutions and general solutions to sine of theta equaling to 1/2. This would happen in quadrant 1 at 30 degrees or pi over 6, and it would also happen in quadrant 2 at 5 pi over 6. We know sine of theta cycles around every 2n pi units. Now we can go back to our original equation. We wanted x plus pi over 4 to be equal to our general solutions. If I subtract pi over 4 from pi over 6, I will get a set of solutions. We would recognize that pi over 6 minus pi over 4, changing it into its common denominator of 12, gives us a negative pi over 12. Therefore, one set of solutions is a negative pi over 12 plus 2n pi. Doing the same thing, subtracting 5 pi over 6 minus pi over 4, giving us 10 pi over 12 minus pi over 4, or equivalently 3 pi over 12, gives us 7 pi over 12. Therefore, x can also equal 7 pi over 12 plus 2n pi, our two general solutions.